If semiconductor were the new oil, then Malaysia is the indispensable giant of this very global industry. Why do I say so? It's the sixth largest exporter globally within this industry. It is commanding 13% of global outsourced semiconductor assembly and test. Now, don't worry if you don't understand that term, I'm going to explain it later. And it also supports roughly 23% of US chip assembly, test and packaging. So in this video, we're going to cover chapter 6 of my book, The Malaysian Multi-Baggers, which is the semiconductor vertical. And I'm going to show you their revenue model, their unit economics, and why we have quiet giants sitting within our footsteps. Hello everyone, my name is John, former engineer turned full-time investor, currently wealth planning director at Phillip Capital, as well as the author of the book Malaysian Multi-Baggers, in which I cover the Malaysian champions that have 10 to even 100 times shareholder return within Bursa Malaysia. So contrary to popular belief, Malaysia's largest export isn't crude oil or palm oil, but is actually the electrical and electronics industry. Depending on the timeline you're looking at, it contributed roughly between 45 to at peak sometimes 65% of total exports from Malaysia. Now this is actually a very dominant industry. It contributes a big part of our GDP as well. And in this video, I'm going to cover, what is the entire global semiconductor ecosystem? Who are the players? Who is right at the top of the value chain, all the way to the players right at the, I would say, closest to the consumer, which is the electronic manufacturing services. Now, don't worry if you're not familiar with this industry. In this video, I'm going to break it down in very layman terms. How do they generate the revenue? What makes them valuable? And who are the players, and what have they what is the shareholder results if you've actually invested in them over these past 20 years. So I start describing the back-end semiconductor ecosystem map. And why not the front end first? Because most of the players within the front end space are actually not located within Malaysia, and Malaysia's strength is not really in the front end, but more of the back end ecosystem. So I'll just verbally narrate what is the front end. So let's say a guy like Apple, they want to design their own phones and they want to design their own chip. So they start off the design there. They will buy certain software to actually make the design. And then they will outsource this manufacturing of the semiconductor wafers to either a Korean company or a Taiwanese company, which have the manufacturing capacity to manufacture at what we call leading edge. Now, it's no surprise these two guys, and even the third guy is Samsung Electronics in Korea, and also Taiwan Semiconductor Manufacturing Company in Taiwan. The third guy, it's more of a CPU player or central processing unit player. They make more computer chips, which is Intel, and that's where they are a little bit lagging or behind comparatively to the Taiwanese and to the Korean players. Now, once TSMC or Samsung or Intel manufactures a semiconductor wafer, the wafer actually gets shipped to either Penang or either to somewhere in KL or somewhere in Johor, that allows what we call an outsourced semiconductor assembly and test, which is OSAT within this slide, to actually cut those wafers, right? It really looks like a chocolate wafer or a strawberry wafer, whatever you like to call it, right? They will slice and dice this wafer into tiny pieces called a die, a semiconductor die. And the job of an OSAT is to package this die, and the packaging is required to protect it, to enable connectors to connect to it. And one of the guys that specializes in doing this is a guy called Inari Amatron. And Inari actually focuses on an even more tight or vertical niche, which is the radio frequency chip. Now, a radio frequency chip, in very layman terms, is used to communicate. These are chips that you find on your mobile devices, your Wi-Fi chips, your Bluetooth chips. They are commingled together with a radio frequency chip to enable communication between devices. And that's where Inari Amatron is a OSAT for usually the RF space, the radio frequency space. Now, they'll slice it, they will package it, right? And then it will ship it off to a electronic manufacturing services player, which we'll discuss later. Now, before they actually ship that chip that is packaged over to an electronic manufacturing services player, the chip needs to be inspected for defects. You know, when you slice and dice the thing, you package the thing, and every step of the way, they need to ensure that the chip is still functioning, you know, because it's subject to, you know, wear and tear, for the lack of a better word. And the players supporting these guys are what we call automatic testing equipment manufacturers. They make the testers to actually test the functionality, the viability of these chips to make sure there's no defect before it passes on to the next stage. So these ATE guys are guys like, you know, Pentamaster, guys like Vitrox, guys like MMSV, guys like Elsoft. The list goes on and on. I mean, some of them are still around. Most of them have multi-bagged, right? But these guys are important to ensure the OSAT players and eventually the EMS players, electronic manufacturing services players, actually have a functioning tested chip. So the last segment before it reaches the customer are what we call EMS players, or electronic manufacturing services. Now, if you go to a shopping mall and you see a Dyson vacuum cleaner, just be aware that it had to go through many steps within this semiconductor industry to manufacture just a chip or even a complete, what we call a product. Or the term that the EMS players normally use is this thing called a box build. That means Dyson will contract the whole box build over to an EMS player like SKP, right, and SKP Resources, and they will bundle all the chips, integrate all the systems, even build the plastic casing through plastic injection molding machines and all that, and package the whole thing, even box it up, and send it over to the place where they're going to be eventually sold. So there you go. This is where Malaysia really shines, all the way from, you know, OSAT, outsourced semiconductor assembly and test. Think of them as like they're the guys that package the cake for you for the chip, right? The integrated circuit or the semiconductor die. Now, there's a lot of terms that are used interchangeably. Obviously, some of them are technically very accurate, but if we go down the technical accuracy route, I think we're never going to finish this video. So think of it like you've got a cake, someone will cut, package it, all right, and ensure that you can connect to the packaging of this slice of cake. And then this cake will actually be tested by machines produced by the ATE players, right? And then after that, they will be passed on to systems integrators, someone who will assemble this whole thing, someone that even labels and stickers the boxes for you and send it so that consumers like us can buy the finished electronic product. So for an OSAT, what is the business model? Remember, their job is to take a semiconductor wafer from a wafer foundry like TSMC or like Samsung, and they will cut, they will slice it, and they will package it, right? So as a business model, how do they charge? They actually think of them like a manufacturer, but they take semi-finished goods and they finish as a semi-finished goods and they pass it on to the EMS player. So in terms of unit economics and their revenue model, it's actually how much volume they produce. And if you go to a big guy in Taiwan, one of the largest guys in the world, is this company called ASE Engineering, okay? Advanced Semiconductor Engineering, okay? One of the largest guys, Taiwan-based, right? Or you can go to someone like Amkor, right? Which is one of the largest in the world too. These guys, unless you get them to, you know, OSAT, probably millions of chips a year, right? Or billions of chips a year, they will not, you know, they will not take on the order. But the beauty about Malaysia is we said that, okay, you give us 100,000, okay, 100,000 maybe too little, maybe 1 million chips, right? And they will say that, yep, okay, we can customize our machine setup to fit your volume, right? And they can't be picky because they cannot compete in terms of volume compared to the Taiwanese, the Koreans, you know, or the Americans, right, or the Japanese. So where Malaysia prides itself is this strategy called the low volume, high mix. That means they've got multiple different products. And why it's a pain for the bigger guys is if you take on 1,000 of each product, your machine setup has to change. So that means when you take on product A, your machine setup is like this. You got to test, make sure the yield is great. Then you got a B product, right? Then you got to rejig your machines to ensure the B product is actually being produced. And that's where a lot of these big players, they ignore. They kind of says, no, I want the volume. And that's the beauty of the low volume, high mix, because that's where you can charge a little bit more margin for the trouble you take to rejig the line. And this is where Malaysia actually is very strategically positioned. So for a OSAT player, in terms of the balance sheet risk, they actually take on a lot of capital expenditure. And because of the rapid change in technology, think of a machine that you buy, it could be obsolete within 5 years or even 10 years or even shorter. And that is the struggle or the disadvantage of an OSAT player, because you're manufacturing and then the manufactured goods changes so fast in time. I've spoken to OSAT players before, and they tell me sometimes within 5 years the machine is obsolete, right? And they have to replace. So there's a very high capex requirement cycle for them to actually replenish. But the beauty about them is they have large volumes, especially if it's on an up cycle where, post-COVID or pre-COVID, and you see demand, during COVID, the demand of these chips rise, then they will rise together with their clients who actually pay them to actually package these chips. So it's a combo of very high capex of machine and combo of skilled labor, engineers, technicians to keep manufacturing these high-tech products. So there you go. That is the outsourced semiconductor assembly and test, or OSAT for short, business model. So the second niche within the semiconductor back-end manufacturing is actually this guy is called the Electronic Manufacturing Services Company, or EMS. What do? Is they will buy or take chips from the OSAT players. They've already been packaged, right? And they will assemble maybe motors, especially if it's a vacuum cleaner, they assemble the motor, they assemble the plastic housing, and final assembly of the finished products that even they, sometimes even these EMS guys, right, they package, they don't even go back to let's say like Foxconn, which is one of the largest EMS guys in the world, right? It doesn't even go back to Apple. It just ships directly from Foxconn's factory in Shenzhen straight to maybe an Apple store in the US, or Apple store in Malaysia, wherever it's located. That is the relationship, because why go back to Apple, right? It's Apple will have to provide for like storage space and all that. They just get EMS guys to outsource all the contracting, manufacturing, logistics, all this headache over to them, right? So the EMS guys are the closest to the final product. Their role is really value chain management, supply chain management, ensure that it's very tight, because margins within this niche is actually very, very low. If you talk about Hon High Precision or Foxconn, one of the biggest in the world, they actually make anywhere between 2 to 3% net margins. So you can imagine how razor thin it is, and especially if you now got forex translation loss and all that kind of thing, you have to run a really, really tight ship. But the beauty about this business is that it's a very large volume. You've got excessive volumes coming through, and that's why it's also very capex intensive, and it's also very labor intensive, because it doesn't make sense, especially for smaller volume products, for it to be automated. They rather hire human labor because it can be trained quite fast to actually build products. But now with automation costs coming down and down, I think more and more of EMS guys will actually automate. But that is I would say, the pro and con of the EMS niche. A lot of the costs, and depending, so if you see the relationship with Hon Hai or Foxconn with Apple wants to control the cost of their raw material, or even the semi-finished products, and that's where Apple catches most of the upside, and people like Foxconn will get squeezed in terms of the margins. The EMS players who actually have a bit of say in procurement, that's where they can make a little bit more in terms of the margin, but it's not great. It's not going to be as good as an OSAT player, or it's not even going to be as good as an ATE player, automated test equipment player, which I'll talk about next. But there you go. That is the EMS niche. Very big volume, a lot of material cost pass through, very labor and capex intensive as well. The third pillar I would like to cover is actually the ATE or automated test equipment players. Now, what do? They build machines to actually test products within the semiconductor industry, and it could be for the OSAT players. It also could be for the EMS players. Now, the difference really is about what kind of inspection methods that they use within this machine that they built. Usually, it's a combination of an optical device, or sometimes even an X-ray device, and an algorithm to tell you whether the equipment or the product under test is functionally and physically good. And this is where whenever an AT player, the key deliverables for them whenever they build something or tester for the client is to ensure that the client gets the yield, right? And to inspect and to make sure that they get the yield, so that the manufacturing process itself has a feedback from this tester to say, hey, something wrong within the manufacturing line because my tester is telling me that you get more defects this batch compared to the other batch. And that's why they have to work hand in hand with either the OSAT player or the EMS player, because they are virtually the brains and the eyes of the line. In the past, a lot of this inspection used to be done by human operators. They'll take a look, and as you train and you get better and better, it gets faster, but no operator will be able to beat the speed of a machine and to be as accurate as a machine, right? And that is where these ATE players actually thrive as their clients actually grow. Now, in terms of cost, in terms of capex intensity, actually they are not as heavy as the EMS or even the OSAT players. Why? It's for a very simple reason. Because of obsolescence, again, a lot of the equipment they buy to assemble and to program and to build these machines, they buy it only usually upon an order. They don't try to stock because it gets obsolete pretty fast. And that's the beauty of it, because a lot of it, the input cost is actually heavy, very much R&D, training, and also writing software. And here, the biggest headache for AT player is usually talent. How do you recruit the best engineers, very high postgraduate level kind of talent to be able to program, build these machines for you? And the output is really, equipment that sometimes sells for $1 million. So the guys who are the pioneers as well as the large players within the US, most of the machines sells upwards of $1 million each. Right, I think where Malaysia plays the advantage is that they are willing to customize, spend a little bit more man hours to customize the machine and to show the clients that, hey, I can service you, I can customize these machines for you, and that's what the clients really like. Now, another part or the beauty of an AT business is that, hey, instead of me just selling to you a machine and I get a one-off revenue, I offer inspection services and also remote monitoring services for the machines that I install. Then it can self-diagnose, it can tell you when it's going to fail, and that's what the ATA players are trying to move towards to, is that it's a machine as a service rather than make transactional kind of revenue only. They also say that, hey, let me do outsource all your remote monitoring and diagnosis of your machines to me, because my technicians know best, rather than, when it spoils, then you come and call us. We can actually predict when the machine is going to fail or you're running it to death, right? And that's where hopefully there's a bigger chunk of this recurring revenue for the ATE players. Now, so there you go. This is one of the enablers that enable EMS and OSAT players to function more efficiently. Last but not least, I'd like to cover two, what I call, one is a service enabler and another one is a component enabler. So the machines, when you run them to actually test the ATE players, right? And in this case, it's not even ATE, it's actually semiconductor front-end manufacturing. So the big players will be the guys from Japan, the guys from the US, and they have machines that manufacture semiconductor wafer that is at atomic scale. Okay, atomic scale. That means you can't see it from the naked eye. Now these machines actually, after maybe a certain thousand number of cycles of manufacturing, these machines also undergo wear and tear. And for someone to go in, they need to clean it, they need to refurbish and service these machines. And one of the guys that is based in Malaysia but has a lot of its revenue actually generated in Taiwan is this guy called Franken Berhad. So what they do is the machines that are housed in a semiconductor wafer fab like TSMC, global foundries like Samsung. Not so much Samsung because the Koreans like to give business to the Koreans, right? But the guys like TSMC, the guys in China, SMIC, they have these machines installed every 1,000, maybe 1,000 hours or 2,000 running hours. They need to take out components or parts that have wear and tear, and Franken will come, they will clean it, they will refurbish it. They are actually material science specialists. And the reason why there's a high barriers of entry to someone like Franken is because when you put in a cocktail of chemicals to clean, okay, you guys, we can't use just normal water, right? Even if they use water, it's most likely ionized water or distilled water or some kind of special cocktail of chemicals. And why this is necessary is because you're cleaning at atomic scale. So Franken, what they do is they have to work with the guys like TSMC, the guys like the equipment manufacturers that they serve, and they will say, hey, I'm going to use this cocktail or formula or chemical composition. We're going to test it out together. And he says, oh, the yield is not satisfactory. It's, let's say 50%. He said, hey, is something wrong with chemicals? Can you tweak it, right? And the equipment guy will say, okay, maybe it's because I should shorten the machine running hour for every service. They experiment, and whatever they do is 2 to 3 years in advance of what we call scale production. So usually they have a very small test line. They will actually test and says, okay, I run 1-2 batches, I see what's the product. When they get a higher yield, they get this, this cocktail, this recipe, right? They will copy this exact workflow and it says, okay, now you run it at scale. Because you have to be so cost efficient. If you imagine if you don't test it out, you don't get the yield, right? And the yield is like 30%. That means 30% perfect, 70% is a reject. Would you dare to scale this process up? Would you dare to use whatever components or cocktails and scale it up? You'll be losing money, right? Unless you get maybe 50, 60, 70, or even 80, 90% scale efficiency yield like TSMC, only then you will be willing to scale up that production process. So Franken is a very critical service enabler, especially for the front-end semiconductor wafer manufacturing. And we're proud to have it that is listed in Malaysia actually. So there you go, service enabler. The other part of an enabler is actually this guy called a component enabler. Now, remember I told you that the automated test equipment guys that actually test this die, semiconductor die. So the die actually needs to be placed in a holder. I mean, you can't just hold it with your fingers, right? It's so sensitive that you need to hold it up in a particular holder, and this holder is actually subject to a lot of wear and tear because you put the chip on and then it gets tested. You have to press it to hold it tight, and then you have to release it, and then there's a lot of mechanical wear and tear to this, and there's actually a certain life cycle to what we call this as a test socket. So any guy that builds a machine, they need to buy this test socket to be installed onto their tester, right? And the moment after a certain life cycle, a certain use cycle, they have to dispose of it. So think of the machine as the razor. So let's say a machine from Vitrox, a tester from Penta, for them to test this semiconductor die, right? That is the razor. And the blade is actually the socket that this component enabler called JF Technologies actually make. The test socket, after you can't shave using the same blade 1,000 times. I can almost guarantee you either it becomes blunt or you're not going to get a clean shave, right? So you have to replace the laser. So it's a beautiful thing that is a consumable, but it's a very, very expensive consumable. I don't think you can buy some of these sockets for $1. I doubt it. It's going to be in the thousands or even hundreds of thousands, depending on the complexity of the socket, right? So the beauty of this is that there's a certain recurring component to their revenue model because it's a consumable. But here the risk as well is that you have to keep up the times because unless you change the socket design to match whatever new technology of how wafer die is being packaged and all that, you will lose out to your competitors. So there you go. You see, right? You've got the big guys like, we only look at Apple as a finished product. Or you think about TSMC as one of the leading edge semiconductor wafer manufacturers. But in order for these guys, or even Inari, in order for these guys to actually produce the product, there's a lot of what we call service enablers, component enablers, machine guys like ATEs to actually support the manufacturing, the testing, the refurbishment, the servicing of these players in order for us to get a finalized product. So I know it's a lot to take in, especially if you're not familiar with the semiconductor industry, but I would like simplify and give you a conclusion of how to think about this industry. Think of guys who are usually the brains or the designers. A lot of them, they don't actually want to manufacture because it's a very high capex intensive model, right? What they do is they'll design all this. These are the fabless guys, and usually they're all located in either the West or in Japan or in Taiwan, right? Or in Europe. And a lot of this manufacturing is actually been outsourced to Asia, right? The guys at the top of the manufacturing food chain, like TSMC, and then you trickle down to the back end where Malaysia really is. We package the chip, we package the chip, and we actually final assemble the product for the consumer. So guys who service enable these guys or component enable these guys, they actually make components, they actually service, they actually build testers for these players. So the model of a manufacturer will be very high capex, very labor intensive, whereas the guys who are component enablers, testers, or even service enablers, these are more brain intensive, for the lack of a better word. Lower capex risk, but a lot of very smart labor goes into thinking, creating a product or a service that is actually very, very niche. So when you invest, when you look at the financial statements, you have to take into concern how each different niche will look on the financial statement. So you cannot be comparing like Vitrox, high margins. You're talking about 20-25% kind of net margins compared to a guy like an EMS, because the EMS guy cares a lot about yield and volume, whereas a Vitrox would be selling machines, probably 300-400 machines a year, and but in terms of balance sheet risk, I don't take on that much, right? So again, it's not an apple to apple comparison. We cannot say like everyone within the semiconductor industry will look exactly the same on the financial statement. And once you get to know the semiconductor ecosystem, that makes you sharper in how to do what we call peer benchmarking. So if you compare Vitrox, you cannot compare it to Inari. Instead, you should compare to other ATE players around the world, in Korea, in Japan, or even in the US. So hopefully I have enlightened you and tried to simplify this very, very complex industry, which, including myself, took many years to learn. Even though I'm an electrical engineer, I never worked in the semiconductor industry. I worked in the oil and gas industry, but it's because of just genuine interest, because I'm an electrical trained engineer, that I really like this industry. And let me know your thoughts in the comments below. Let me know, what do you think are the best niches to invest in within this industry. And if you are free on the 28th of March, 2026, on a Saturday, I'll be hosting a book signing ceremony, book autograph ceremony in MPH TRX at 2 p.m. So Saturday, 28th of March, MPH TRX, 2 p.m. I look forward to seeing you there, and chill out and just talk about stocks.